Welcome to the online class Standard 8 Subject Physics. I am Amos Michael, teaching physics in Mount Zion Matriculation Higher Secondary School. In this lesson, we are going to learn about light energy, but in this class, we are going to learn more about light and its properties. What is a light? Light is a form of energy. It is responsible for the sensation of sight. So in the dark room you can't see anything. So with the help of light we can able to see things. There are two types of things, luminous and non-luminous. So luminous objects are sun, candle, bulb, which will emit the light energy from its own, whereas non-luminous bodies, they does not emit the light from their own, but they will reflect the light from the sun, bulb or candle. So examples of non-luminous bodies are moon, mirror and etc. And we should not forget that the light, it travels in a straight line. So what do you mean by rarer medium and denser medium? A transparent substance in which light travels is known as medium. Example: air, glass, certain plastics, metals, water and kerosene. A medium in which the speed of light is more is known as optically rarer medium, or in other words, a less dense medium. Air is an optically rarer medium as compared to the glass and water. So a medium in which the speed of light is less is known as optically denser medium. Glass is an optically denser medium than air and water. What are the causes of refraction? The speed of light is different in different media or substances. For example, the speed of light in air is 3 into 10 to the power 8 meter per second. That is 3 followed by 8 zeros. So in other words, we can call it as 3 lakhs kilometers per second. Whereas that in the case of glass, it is 2 into 10 to the power 8 meter per second. It is clear from those values that the speed of light is more in air but less in glass. In other words, the light, it travels faster in air but slower in glass. When light goes from one medium to another, its speed changes, and this change in speed of light causes the refraction of light. Note that the difference in speed of light in the two media greater will be the amount of refraction, that is the bending of light. What are the two rules of refraction? There are two rules for the direction of bending of a ray of light. So what do you mean by refraction? Refraction is nothing but the bending of light ray when it travels from one medium to another. So there are two rules of refractions. One is when a ray of light goes from a rarer medium to a denser medium, it bends towards the normal. Look at the first diagram. So this is your incident ray. So air is the rarer medium, and this one is the glass, that is the denser medium. When light travels from a rarer medium to denser medium, that is from air to glass, it deviates towards the normal. That means it bends towards the normal. So the actual direction of the light should be in this way, but the light, it bends towards the normal. This one is the normal. What do you mean by normal? It's a perpendicular line drawn at the point of incidence of the incident ray. So when a ray of light goes from a denser medium to a rarer medium, it bends away from the normal. So look at here, this one is glass, a denser medium, and this one is air, a rarer medium. So when light passes from a denser medium to rarer medium, it is bent away from the normal. So that is this one is called the normal line. This is a perpendicular line drawn at the boundary, and the light, it bends away from the normal. So The actual path of the light should be like this, whereas it bends. Why? The light travels faster in rarer medium. So as the light travels faster, so it goes away from the normal direction, normal line. What do you mean by refraction? Now we are going to see in detail about the refraction. So as I told earlier, the bending of light when it travels from one medium to another medium is called refraction of light. Look at this diagram. This is nothing but the incident ray. It falls on the boundary, and this point is called the point of incidence. That is the point at the boundary in where the incident light ray falls on the boundary. So this is the normal line. So already I told you, so perpendicular line drawn at the boundary at the point of incidence. So this is the incident ray. So this one is the normal, and this I, letter I denotes the angle of incidence. This letter R denotes the angle of refraction. So the angle between the incident ray and the normal is called angle of incidence. So the angle between the refracted ray, that is this one is the refracted ray. The angle between the refracted ray and the normal is known as angle of refraction. Similarly, in that boundary also, this is one is the angle of refraction, and this one is the angle of emergence. So in this video we are going to see in detail about the refraction of light. So look at the video. So when light falls on a surface, what happens? So light is made up of large number of rays. For the sake of simplicity, we have taken only one ray. So when it falls on a surface, either it will be reflected or transmitted or absorbed. So depending upon the nature of the substance, it will be absorbed, reflected or transmitted. What do you mean by opaque object? It reflects most of the light. What do you mean by transparent object? It transmits most of the light. So when a light ray fall on a mirror, that is a reflecting medium, so most of the light is reflected. Here the angle of incidence will be exactly equal to the angle of reflection. So whereas in the case of a transparent object, say for example glass, so it transmits most of the light. Of course it will reflect a part of the light, but it will transmit most of the light into the other side of the medium, that is glass, like this. Now once again we are going to see what do you mean by refraction of light. So bending of light when it travels from one medium to another medium is called refraction of light. So here the light ray incidence at the point, this one is the boundary of the glass surface, and it deviates towards the normal. You take the glass slab, and outside this glass slab you will having air. So when a light travels from the air, its incidence obliquely. The obliquely means, what do you mean by obliquely? Slanting, that is neither parallel nor perpendicular. So it falls obliquely, that means it falls slantingly. It makes an angle with the boundary surface. So it is get refractors. So if the light goes in this direction, it is not refracted, whereas here the boundary, its direction is, what happens is it bends towards this normal. Okay, so look at this diagram. So this one is a rarer medium, this one is the denser medium, where the incidence ray travels faster, and here, so since it is a denser medium, it travels slower. That's why it bends towards the normal. Whereas when this ray travels from a denser medium, that is from glass, to a rarer medium, that is air, it deviates away from the normal line. Okay, so these 2 points are called point of incidence. So a perpendicular line, imaginary line, is drawn at the point of incidence and is called normal. So the angle of incidence is nothing but I. It is denoted by the letter I. This is the angle made by the incident ray with the normal is known as angle of incidence. Similarly, what do you mean by R? R is nothing but angle of refraction. That is, the angle made by the refracted ray with this normal line is known as angle of refraction. Okay. So what are the effects of refraction of light? A stick or a pencil held obliquely and partially immersed in water appears to be bent at the water surface. Look at this video. This man is going to put two pencils on the glass tumbler. So he is placing the pencil and it is held obliquely, and he is going to pour this water into the glass. So it is partially filled. So you look at these two glasses, and if you look at this glass, the pencil, it is held obliquely and it is partially immersed in water, and it appears to be bent at the surface of the water. So look at this here, it is appears to be bent because light travels from different medias, that is from water to glass and then into air. So this phenomenon of bending of light at the interface of two media is commonly known as the refraction of light. So next effect of refraction is an object placed under water appears to be raised. Here if you place a coin, it is the true position of the coin, and if you look at from the top of the vessel and it appears to be raised, so actually the coin will be here but it will appear to be located here. So why? Because of refraction of light, it appears to be raised. Okay, next application is, that is the effect of refraction of light, is a lemon kept in water in a glass tumbler appears to be bigger than its actual size when viewed from the sides. So a pool of water appears to be less deep than its actual depth. So look at the, if you look at the pool from the upper side, and it appears to be less deep than its actual depth. So next one is, when a thick glass slab is placed over some printed matter, the letters appear raised when viewed from the top. So here a letter WebGR, over the letter WebGR a glass slab is placed, and you look at, if you look at this glass letter from the upper side, that is from the top side, and you will see like this, this is, and the letters appears to be raised when if you view it from the top. Fifth one, the star appeared to twinkle on a clear night because of refraction of light. Okay, so the refraction of light causes advanced sunrise and delayed sunsets also. So next topic we are going to see the laws of refraction. What is the first law? That is the incident ray, the refracted ray and the normal all will lie in the same plane. This one is the incident ray, and this one is the refracted ray, and this one is the normal, and these three things will be in a same plane. Okay, that is the first law of refraction. What about the second law? It says that the ratio of sine of the angle of incidence, that is sine I, to the sine of the angle of refraction, that is sine R, for any two media is always constant. That is sine I by sine R is equal to constant, and this constant is called mu. This letter is denotes as mu. The constant mu is called the refractive index of the second medium with respect to the first medium. So this mu it will gives the constant, that is this mu that is nothing but a constant, will give you the refractive index of the second medium, that is medium 2, with respect to the first medium. Okay, and since this law was given by Dutch astronomer Willibald Snellius, it is known as Snell's law. Okay, we will see the continuation of the this topic in the next class. Anyway students, I hope you will understand the concept very clearly, and we will see in the next class. Thank you. Have a nice day.